Good afternoon, everyone. Thank you for coming. What I'm going to be talking about today is two things. The first is spaghetti, which probably after lunch we don't need to hear about. And the second is OSGi and how OSGi can be made to work in a modern business environment. So, do I know what I'm talking about? Well, maybe. Certainly, some people think so. I'm a developer with IBM. I've been with IBM for 12 years now, so true blue. I've worked on a bunch of things. Right now, I work on the WebSphere Liberty profile. I've also done a lot of work with OSGi, the OSGi applications programming model. In a former life as well, I did a lot of work with Java performance. So I've moved sort of all the way from the bottom of the stack to the top of the stack. I'm also an Apache Aries committer. And finally, I have written a book, so I must know what I'm talking about. So the book is Enterprise OSGi in Action. It is very literally hot off the printing presses. It left the bindery on Friday, and I was hoping that I could have a copy today. But it is somewhere on a DHL van. There's a box that has my copies of the book. But you can buy them from Manning. So there we go. Paper copies currently on a DHL van. And this is why ebooks are such a good thing. So let me start off by talking a bit about Enterprise OSGi and why you would want such a thing. How many of you are using OSGi at the moment? A few hands. How many of you think you might like to be using OSGi? A few more hands. So for those of you who didn't raise your hand to either question, I don't know what you're doing here. But hopefully by the end of the talk I'll have changed your mind. So let me step back, though, from why you might want to use Enterprise OSGi and talk about why you might want to use OSGi at all. And the answer is pretty easy. And this comes back to spaghetti. So spaghetti was, it was a huge problem when we started back in the mists of time with computer science, and we had go-tos everywhere, and we had these big long things, and then we thought we'd fixed it, and we thought we invented object orientation, and we thought, that's it, no more spaghetti code, everything is really nice. Well, sort of. Java did make things a lot better. It gave us objects, and what objects did is they gave us encapsulation and abstraction, so they allowed us to keep our dirty laundry private. And this is a pretty good thing. Unfortunately, Java only allowed us to keep some of our dirty laundry private, because we still have jars. So why are jars a bad thing? Well, jars in themselves are not a bad thing. They're a good thing. They're a very convenient way of packaging code. Unfortunately, the clue to the problem with jars is in the picture. Because if you go back, you can see that jar is transparent. Everything that's in the jar, you can see. So Java, it had this wonderful modularity that was really baked in. So classes encapsulated data, and a class could choose to expose that data, or it could choose to keep it private. Similarly, packages contained classes, and you had a similar choice. So you could keep a class private to that package, or you could expose it. And then you went on to jars, and then all of a sudden the whole system collapsed. And all this modularity that you had, and this way of keeping your private things private, it just disappeared. Because there's absolutely no jar-scoped access modifier. There's no way that you can say, I've packaged this in my jar because I need it for my internals, but please don't go using it because it may change. Once something is in a jar, it's on the class path of every single thing that puts that jar in its class path. And that's not a safe way of programming. That's not a good way of keeping your system robust. So there we go. Jars are transparent. No encapsulation, no abstraction. But it actually gets even worse than that. Because jars have no way of declaring dependencies. So if I've written my wonderful jar, and I've used a few libraries because I didn't want to, reinvent wheels. I give you my jar. You try and run my jar. Unless I've also given you a document that says you're going to have to install this, 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 and this for it to work. there's two things that will happen. The first thing that will happen is probably that you'll fire up the jar, you'll start running it. At some point, you'll get a class not found exception. If you're lucky, that will happen quickly. If you're unlucky, 2 weeks into your acceptance testing, after you've moved the system to production, you then discover the code path for which you were missing the dependency. And this is, I think, a pretty unacceptable way of doing things. There's just no way with a jar of saying, what other jars do I need? And you can't even really know very well in a running system, well, what jars am I using? What jars have I even put on my class path? Because the class path is so complex that you've really kind of lost control of it. So let me give an example. This is a fairly small class path. And each of these boxes is actually representing a library. And if I want to look up a class, I've got a class. It has some other dependency. What does the JVM do under the covers? So this is the point where the people filming me aren't happy with me anymore as I start wandering all over. But we start right at the top up there. So we look in the Java VM, we look in its jars, then we keep going, we keep going. Is it in this one? No. 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 At this point, you're happy that you've got a fast computer, but you wish you had one that was faster. Is it in this one? No. Is it in this one? And we keep going. Is it in this one? Is it this one? Is it this one? Is it in this one? Is it this one? Are we bored yet? Is it in this one? Is it this one? You know, this is a pretty tedious way of having internals. But then, finally, we get to the end of the list. We've looked in every single class that we have loaded into our runtime. Great! What happens? A class not found exception. So we had to do all that work just to discover that we didn't even have the thing that we were looking for. So this is crazy, I think. So why would you use OSGi? Well, modularity is a big one. These systems that I showed you there, they're so big. You know, that was a fairly small example, and it was long. And each box represented a whole collection of classes. What about if you get, you know, an enterprise container? It's even bigger. So, you know, you've got all of these APIs. You don't really know which ones you need. You don't really know which ones you're using. And they're all mashed in together. And what that's representing is a moderate size application server. And when you look at the number of boxes there, you begin to understand why application server vendors themselves have been using OSGi for their internals for a long time, because it's actually the only way, or one of the only ways, to write an application server that behaves sanely in terms of its development, in terms of its deploying. But big applications, some of them are actually as big as that. So what do? Well, they continue to have these problems. So Java's been around for a while, and we're beginning to see some evolution problems, because we wrote lots of libraries, and that's really good. So I think I've been using Java for maybe 14, 15 years. In that time, I've seen a lot of libraries come and go. And some of them started out, and then we had better ideas, so we added new ones. And then we had better ideas, so we made some changes. And so this means now we have this absolute mountain of legacy libraryness in Java. The problem is that as far as our code is concerned, these libraries look exactly the same. Apart from a version number that I might write down in the jar name that Java has no way of understanding, there's no way my code can tell the difference between, you know, JUnit 1 and JUnit 4. It might be able to tell because there's a library it needs that's missing, or a class it needs that's missing, if it's lucky. If it's unlucky, you just get these really subtle, niggly behavior differences that you can't really test for in any reliable way until, again, 2 weeks into production, you discover you went down the wrong path and you hit the wrong behavior. And this is why we absolutely need versions. I think versions aren't the most glamorous topic. If I'm honest, I think versions are actually a little bit boring. But they're one of those necessities that in a mature system that's been evolving, or in a mature ecosystem that's been evolving, like Java, you absolutely need versions. And the reason is the same as we need versions on our food. You need to know when you have something that's fresh and good, and you need to know when by accident you've picked up something that's actually rotten. It's been allowed to languish in the bit bucket for too long. It doesn't do what you need to do. If you use it, it will give your application food poisoning. So versions are important. They're easy to ignore because they're boring. Please don't ignore versions. Please do think about versions. They're an important safety feature. So, why OSGi? Well, I've been talking for 10 minutes, and I hope by now I don't need to say much more about why OSGi. I hope by now you're actually sold on the benefits of OSGi and you're looking at your systems and you're thinking, oh, actually, this system is a little bit scary. But let me spell it out. OSGi gives you internal internals instead of public internals. I hope just from the words it's obvious why that's a good thing. It gives you declarative dependencies, so you can communicate effectively, programmatically, about what your application needs. It gives you versions, so that you can be safe when you accept these dependencies. And you can have versions on your jars, which is good, and you can have versions on your packages, which is very good. One of the other things it gives you, which I haven't talked about yet, but which I think is one of the really big use cases for OSGi, is that it gives you dynamism. So a normal Java class path, it's a pretty static thing. Unless you go away and you do crazy tricks and you start writing your own class loaders and you start doing your own things like that, what's on your class path stays on your class path. If you decide that you want to swap your implementation, well, that's fine. All you need to do is restart your whole application. Sometimes this isn't really good enough. I was talking to someone over the lunch break, and they were writing a market application. And what it needed to do is it needed to connect to the system Monday morning, first thing, and it couldn't disconnect. Because if it disconnected, it lost its place in the queue. But they needed to be able to apply maintenance. So they were using OSGi because OSGi allowed them to dynamically restart, refresh, update parts of their application while the rest stayed up. So it gives you this hot update facility that you just don't get in normal Java that can give real business value. So, in other words, things can go away, they can come back, they can go away, they can come back. So, given that you've got these requirements, well, why OSGi in particular? Well, I sometimes see people and they say, oh, I need these requirements and I need some dynamism and I need to be able to compartmentalize my application. So what I'm going to do is I'm going to start writing class loaders and doing this. And I look at it and I think, please don't re-roll OSGi. OSGi is already there for you. It's just waiting to be used. And OSGi, it's an incredibly mature technology. It's almost as old as Java itself. And it's been maturing in that time. It's been hardened in that time. I think we sometimes look around and we think, oh, OSGi, it's a bit of a niche technology. Well, not really, because there are bits of the Java ecosystem that use OSGi that we just never see. There's this whole world of embedded devices, by which I don't mean phones and these sort of modern, newfangled embedded devices. I mean things like set-top boxes, cars. They've been using OSGi for ages. They're continuing to use OSGi because OSGi is the only thing that allows them to get their system fitting into these constraints of these really tiny embedded devices. Eclipse obviously uses OSGi internally. Like I said, embedded systems, home automation, all these use OSGi. There are some quite crazy places you can find OSGi. Like apparently, if you have a BMW 5 Series, that has OSGi inside it, which I just find very cool. And as I said before, the other place where OSGi is fairly universally used is JEE application servers themselves. So their internals, they're built using OSGi because it allows them to scale. So, job done. You're all thinking, that's fantastic. I'm sold on OSGi. I'll have 6. So, what's the problem? Why, when I asked how many were using OSGi, did only a handful put up their hands? Well, OSGi works really, really well if you're writing a BMW 5 Series, or if you're writing an application server, or if you're writing an IDE. For those of us who aren't writing IDEs to embed in our cars to put in application servers, we maybe want to use things like wars, JPA, transactions. This traditionally isn't OSGi's strong point, shall we say. It's not what it was designed for. You could make it work, but you had to do quite a lot of uphill struggling, reading of web pages, tweaking around under the covers. So that's too much like hard work, right? Well, this is where Enterprise OSGi comes in. So Enterprise OSGi, it's a relatively new member of the OSGi family. It's been around since about 2010. And the aim of this is to improve OSGi support for enterprise tools. So enterprise is one of those words where I never quite know what people think when I say it. How many of you yesterday were there when Kevlin was saying that enterprise, he used it just as a euphemism for bad programming? So yeah, I sort of saw that and my heart sank because I thought, but I think I do enterprise programming. And when I think of enterprise programming, I use it to mean distributed programming, things like web applications, things like these value-added services that we actually do need, like database access, like transactions. So how many of you in the audience would consider yourselves enterprise programmers, either in the bad sense or the distributed? Yeah, most of you. Good, good. Enterprise OSGi, the support for it is pretty good, and it's growing. So there's lots of open source and commercial servers that have support for this programming model. WebSphere is one. That's one I obviously know well since I helped develop it. There's also Apache Aries, there's Eclipse Virgo, there's JBoss. Glassfish has a kind of an interesting hybrid model. It doesn't have the full programming model, but it's got a lot of it. So Enterprise OSGi, it really is all this good stuff with OSGi, but just made so that it works quite painlessly with enterprise applications. So you can do your OSGi web applications. So you can use databases. You can do managed transactions. One thing I haven't talked about, which is quite useful as well, is remoting services. So you can use OSGi for remote access, and it works really quite seamlessly and nicely. So if that's something you're thinking about, do come talk to me and I can point you to some resources. So why would you want OSGi in your war? Because after all, a war is a fairly lightweight thing, right? Well, maybe. I was amused because I was in Marcus's talk this morning, and he was talking about how he's seen wars that are 68 megabytes big. Now, 68 megabytes, you sort of think, oh, well, it's smaller than a movie, right? Well, yeah, it's smaller than a movie, but it's 10 times bigger than Tomcat. That's kind of embarrassing if your application is 10 times bigger than the server it's running on. Even, again, WebSphere Liberty Profile, which is a full-featured application server, that's around 50 megabytes. So that's smaller than the applications. So why is the war so big? After all, can it really be doing that much? Well, probably not. What's probably happened is you used a library, and you weren't sure if it was going to be available in your environment, so you put it into your war, because better safe than sorry, right? And then you used another library, and you put it into your war, and then you thought, oh, well, I might someday need these, and I don't really know if I'm using them or not at the moment because I can't actually tell because I don't have declarative dependencies, so let's shovel all those in. And then Maven came along and it said, you know what? You might need these as well. And then 68 megabytes later, you've got this massive, great big war that says hello world. So again, Maven, it is a bit of a culprit in this. And one of the other problems with wars is that they are really pretty static. It's a web application. If you create it in Eclipse, it says dynamic web application. You think, great. But it only means dynamic in terms of the things you code in. You can't change it later. So, if you want to just extend your application a bit, and you need to restart the whole thing, and there's actually customers coming in, you're stuck. So, one of the things that's really important with war programming, as with other programmings, is to understand your dependencies. And that helps you at build time, so that you don't put the whole world in your war. But it also helps you understand your design. What other code does my code touch? And that becomes sort of an internal thing. So rather than thinking, what libraries am I using? Even within your own architecture, is your architecture clean? Have you got spaghetti within your architecture? Can you safely change bits of your application? Well, maybe, maybe not. Will OSGi solve all your spaghetti problems? Well, maybe, maybe not, but it will help. So, why else would you want OSGi? We have a problem again with versions in Java, and this problem gets worse once we start running in a container. So you've got a library, and you depend on your version of the library, and that's fine. And it depends on library C at version 1, which is fine until you add library B, which also depends on library C at version 2. The class path can only have one of these loaded. You can put as many as you like on your class path in the string, but Java will always use the first ones it comes to. So this usually means one of your libraries is really happy because it's running as it was designed. The other library is having a car crash because the library doesn't expect to be, it doesn't behave the way it expected. Maybe classes it needs are missing. At best, the behavior is different. And this kind of problem you can't even discover until deployment time, and you can't fix it full stop. So OSGi completely fixes this problem, as long as you have versions, because you have a class loader graph. So here's your jar. It depends on these two things. Each one sees its own version of library C. Because the class loader, or the class space, instead of being this long linear string, it is this graph. These things can coexist because each bundle has its own version of the class path that it sees. And this has a lot of advantages. It's spectacularly efficient in a large system because instead of having to do that really tedious search through everything, you only have to look through your dependencies. And it also means you get this robustness increase because you don't run against the wrong version. So I've said here optimistically it all just works. And it all just works is one of those phrases that I think gets abused. But I think in this case, it really does all just work. It's a very neat system. So if you want to get started with this, if you want to do it yourself, what do you do? Well, you've got a good choice of application servers. Or you can, if you want to do something a bit lower level, there's libraries available. So there's Apache Aries, there's Eclipse Virgo. You can just pick up the components that you want, roll your own framework. There's also Apache Carafe, which is a very nice little OSGi runtime. With most of them, all you have to do is just package your application up as an OSGi bundle. If you haven't written an OSGi bundle before, this may sound daunting. It's not really. There's lots of tooling support that makes it easy. So an OSGi bundle, it's just a jar. Good, good, good. So you get that backwards compatibility. And it's got a special manifest. So a normal jar, the manifest is pretty boring. In fact, it's so boring that it's hardly worth putting it in. With an OSGi bundle, the manifest's a bit more interesting. So you have a bundle symbolic name, and you have a bundle version. And once you have these, your bundle's good to go. But you probably want to put in some other things as well. And so this is where you've got your declarative dependencies. You say, I need these packages. If I don't have these packages, I am broken. Please don't start me. You also perhaps want to export some packages. Again, other bundles can import these. So this is great if you wanted a jar. But of course, I've promised you a war, and I've promised you a web application. So the good news is that wars and jars are actually pretty similar. A war, it has a different internal class path, so it's got webinf.lib, webinf classes. But apart from that, it's pretty similar. So the manifest is in the same place. A war also has the web XML optionally. And you can put nested libraries in here. So at this point, you might be thinking, oh, well, those look pretty different, actually. How can OSGi cope with all of that? The good news is OSGi already copes with all of that, so there's not that much that needs to change. So in an OSGi bundle, you can declare a class path for that bundle already. So all you have to do is say the class path for my bundle is webinf classes and webinf.lib, and you're good to go. Which is good, because before we added the little extra last bits of hooks that could let you run a war in OSGi, it was a bit of a pain. There was something called the OSGi HTTP service. It was there if you needed it. It was not a transparent migration from a war. You couldn't just take your war and drop it into your OSGi environment and go, I'm good to go. So the enterprise specification, it really did make things simpler. And the thing that it did, which was so good and such a right decision, was it allows you to just reuse all of your existing deployment descriptors, all this collateral that you've built up with pretty minor changes. So the OSGi equivalent of a war is called a WAB, which is a web application bundle. And just like you can be a jar and a bundle at the same time, you can be a valid war and a valid WAB at the same time. And so that's cool, because it doesn't mean when you move to OSGi you're burning your bridges. You've added a bridge, but you can always run back across it if it's too scary. So an OSGi bundle, it is an OSGi bundle, or a web application bundle is an OSGi bundle. You have the same OSGi metadata. The thing that identifies it as a WAB, so if you go do this yourself, the one thing that you absolutely have to add is the web context path header. And this lets the container see, oh, this is a WAB, let me do the right thing. And again, if you want it to have that interoperability, you do have to add a bundle class path so that the slightly strange war class path works within OSGi. So with all that, what do you have? We've got your OSGi bundle. You've got your OSGi headers. You've got your web context path. And then you've got that extra bundle class path. And there you are. You're good to go. As long as you have the right container, it all just works. So why would you want to do that? Given that these two are interoperable, you haven't gained very much. Well, in particular, your 68 megabyte war is still a 68 megabyte war, but you've just done a bit of extra work. Well done. The reason this doesn't look so exciting yet is that you're not actually using any of OSGi's features. Once you start using them, you lose a bit of your ability to run back across the bridge, but you gain a lot. In particular, once you start importing your packages, you can take all that 68 megabytes that you had in your jar, and you can move it somewhere else safely, because you know that no one's going to try and run your war without those dependencies. And you can do that for the transitive dependencies as well, because you don't need to try and guess what the dependencies of your dependencies are, because OSGi, it guarantees them. So how would you do it? What steps would you take? Well, tools help a lot. I would always recommend using some sort of tools. There's two schools of thought for OSGi tools. And this is the great manifest debate. So if you want to do these sorts of things, you can go to the OSGi forums and you can find people getting really, really heated and telling the other people that they're idiots and how could they possibly think this way. I can kind of see both sides of the debate. So one approach is a manifest first approach. And this says that if you're doing OSGi, the manifest is one of the most important artifacts. You want to have full control of it. You want to write it yourself. The other approach says that a bundle manifest is actually a bit like Java bytecode. You'd want to write the Java code, but you wouldn't want to write the bytecode unless you're some people. So let the tools write the manifest, and you just do the interesting things. That approach makes things a lot easier. It can sometimes lead to surprises if you don't actually know what your dependencies are. So if you want to do it manifest first, the easiest and best way to get started is Eclipse PDE. It's a bit misnamed because PDE stands for Plugin Development Environment. And it was originally intended to allow you to write plugins for Eclipse itself. But because Eclipse is OSGi, that means that it's actually a really good environment for writing OSGi bundles. Once you get into build, you can use stuff like Maven Tico. That kind of integrates the Maven way of thinking with the Eclipse way of thinking. You can also just use Ant. If you want to do it code first, in a way you have more choices. Because at development time, you're writing it exactly as if you weren't using OSGi. So you can use whatever tools you like. You can use whatever IDE you like. Once it comes to build, you obviously do need to get something in to write your manifest for you. But Maven has pretty good integration. So if you're using Maven, you can just say, I want a packaging type of bundle rather than a packaging type of jar. And it just works. If you want to do Enterprise OSGi stuff, WARs, JPA, JTA, all that kind of stuff, there are some tools in this area as well. So there's an open source project, Eclipse Libra. There's also what I'm going to be showing you today in a demo, which is IBM's OSGi application development tools. And both of those, they're actually related to each other. And they both sit on top of Eclipse. They take advantage of all the Eclipse web development tools, but they also take advantage of the Eclipse, the PDE bundle development, and they combine those two quite nicely. So what do you do when you have third-party libraries? Because you're sold on OSGi now. Unfortunately, the rest of the world, it isn't all using OSGi. How do you go about it? In a lot of cases, you sometimes see posts on forums and someone says, where can I find a bundle version of this library? And the answer comes back and says, that library is already a bundle. You just hadn't noticed. So that's pretty easy. Sometimes the version you're using isn't a bundle, but the next version up is a bundle. So that makes it pretty easy. Alternatively, if you're using a popular library, someone's probably converted it into an OSGi bundle already. So there are repositories. On Maven Central, it's a bit annoying the way it works, but you can find lots of bundleized versions of jars, and the group ID is different, but the artifact ID is the same. So you need to know where to look. But if you know where to look, they are there. And the final thing is that if you're using this jar, and they haven't converted it to an OSGi bundle, and no one else has bothered to convert it to an OSGi bundle, you maybe want to question whether you're using the best of breed. If this jar is so obscure that no one could be bothered to convert it to OSGi, maybe you should look at an alternative. If you absolutely have to be using that jar, you can just wrap it and convert it into an OSGi bundle. So it's a one-line step. You can download the BND tool, you type BND wrap, and it spits out a bundled version of the jar. Finally, if even that's not good enough, what you can do is you can go back to that webinflib trick, and you can take this jar, you can put it inside your bundle on the class path of your bundle, and then it doesn't need to be a bundle. So here's some links for finding these OSGi-fied bundles. You can wrap it using BND. So embedding jars, it's sort of one of those I think dirty things where in an ideal world we would never do it because it doesn't, eliminate this advantage of OSGi of keeping your dependencies external. But it does have some advantages as well because not everything is written with obviously not everything is written with OSGi in mind, but some tricks that applications do can tie OSGi in knots. And if they do things like reflective class loading, that can cause problems. If your third-party library is embedded in your bundle, it shares the class space with its consumer, and that can sometimes eliminate some problems. So finally, I talked a bit about OSGi dynamism. And that's a really good thing and one I wish I had more time to talk about. And one of the things that goes along with OSGi dynamism is OSGi services. They're sometimes called microservices. Are any of you using them? One hand. Have any of you heard of OSGi services? Okay, a couple more hands. OSGi services, I think they're one of those ideas that were so ahead of their time. They allowed you to do this loose coupling and this dependency injection, again, 10 years ago. And we're starting to get much more towards that model now with, the standardization with CDI and that kind of thing in the non-OSGi space. But OSGi services still have some fairly killer advantages in terms of how dynamic they are and in terms of being able to, to swap out your dependencies dynamically at runtime, and the consuming application doesn't even notice. But the main thing that OSGi services allow you to do really neatly is solve the factory pattern, which again, we're getting towards solving with CDI. But the number of times that I've seen in code, and I've seen, the something factory, but then we didn't know how to get hold of the something factory. So then we had the something factory. And I have actually seen the something factory. And at the point when you have a factory, you know that maybe you're using the design pattern wrong and that you need to go away and look at a different technology. So what OSGi services allow you to do is they allow you to look up a service based on the internet interface. So you say, I want an org.something, and the OSGi framework just gives it to you. I think one of the reasons that OSGi services maybe haven't set the whole world alight is that the interface is not nice. So don't use the interface. Use something like declarative services or Blueprint to inject your dependencies for you. It makes life better. So now what I'm going to bravely attempt is a demo. I've seen quite a few demo car crashes in the last 2 days, which is good. It makes me feel a bit better because my demos are always car crashes. So what I've got here, what I'm going to show is I'm going to start with a simple web application. This is just a vanilla web application. And I'm going to show converting it to OSGi. And I'm going to show running it in 2 environments. So one is the WebSphere Liberty profile. So that's a full-featured application server. The other environment in which I'm going to show it running is Apache Carafe. And that's about as small a container as you could get and still have a container. And so normally, if you had an application that was going to run in these 2 totally different environments, you'd have to do that defensive programming. And you'd say, OK, well, I need SLF4j, and I need this, and I need that. I have no idea what the container is going to provide me, because these 2 containers are so different in scale. So let me just shovel everything into my war, and it will all be OK. So I've just got a simple little JSP. It's got a little dependency. This time displayer class. And the time displayer has a dependency on Joda date time. I was so disappointed when I worked out it was pronounced Joda and not Yoda. I really thought it was pronounced Yoda, and I thought it was lovely. So of course, I have no idea whether, I keep pronouncing it Yoda as well. I have no idea whether Joda is going to be available or not. So I've got it in my webinf lib. So let me run this on my server. You can see I've got it deployed here. I've got WebSphere here. I've got my little server. Let me run it. Yes, I want to run it on WebSphere. Oops. Hooray! And you can see I'm not cheating, and this is live, because it's 15:10. Great, so now I want to convert this to OSGi. Well, Eclipse has some tools to help. So if I right-click and do Configure, Convert to OSGi Bundle Project, so it's now converted it. And I have a manifest. I had a manifest before, but it was very boring. Now I have a more interesting manifest. You can see it's made some choices for me that I wouldn't have made myself. So for reasons I don't understand, it's worked out I have this Jota time dependency, but instead of giving me the one in my lib, it's giving me the one about 5 directories up. So we're just going to ignore that and say we want that one. I'm also going to import some extra packages. It's also given me an import package for Jota time, which I don't need because it's still in my bundle. So now, moment of truth. You can see I've got a bundle symbolic name. I've got an import package. What I haven't got is I haven't got a web context path. So I'm going to add that. And I'm going to say block stacker web. And I did have a red cross up there, and that red cross was Eclipse telling me, hey, by the way, you look like you're trying to do a web application, but you don't have a web context path. So I've added that now. And now I need to do an extra step. So I had just deployed my war directly to my server. Now that it's an OSGi bundle, in WebSphere I need a higher level of granularity. So the assumption is that I'm not very often going to deploy just a war. So I need the OSGi equivalent of an EAR, which is an EBA. So if I do a new project, and I want an OSGi application project, let's call it blocks EBA. So now on my server, I'm going to remove the old war. And so you can see I've stopped the old war. And I'm going to try and run my new EBA. So I'm going to run it on the server. And this isn't entirely encouraging. It's not doing anything, is it? No. Let's try and kill that off. Let's try again. Nope. Nope. I should say, I think it sort of goes without saying that, of course, this all worked brilliantly this morning when I tried it. So, let's see, what can I do? I was impressed because I went to the Tommy talk yesterday, and he had a demo catastrophe. And every time it went wrong, instead of trying to patch it up, and he thought, right, I'm just going to erase everything and start again from scratch, which I thought was a really sort of admirable way of ensuring that you don't get into this spiral where things don't work. But unfortunately, even erasing everything and starting from scratch continued going down the spiral that things don't work, which just goes to show that sometimes it's not going to work and it's not going to work. So let me see what's going on with my server. I'm just going to open the server configuration. It doesn't think it has any applications installed. While I'm passing, I will just say because this isn't a vendor pitch, but I do work on WebSphere, and we are really proud of what we've done. WebSphere, it's all OSGi inside. And with Liberty, it's super, super lightweight and it's super dynamic, and you can take features away and add them back. So, you've got this full-scale application server, but then sometimes you don't want that. You just want something really small. And so you can list these features here, and when you don't list the feature, it's not loaded into the runtime. And so that does mean that you can have a runtime with a super small footprint. And what enables this, and the reason I'm saying it isn't just because I think it's really cool, but because this is OSGi, that enables that to work. It just wouldn't be possible without OSGi. So, run on server. Okay, so the application was not started. So it can't provision the EBA block CBA. So you may think at this point that it's going wrong, and that's right. But quite often, this is actually exactly what you want to happen. So I've got something wrong somewhere, and some dependency that I thought I had, I don't have. And my server, instead of letting me get all the way to where I go to the web page and then I get a stack, a class not found exception, instead it's saying right off the bat, look, you don't have what you need. I'm going to fail fast, because failing fast is much, much better than failing slow. So the bundle dependency blank. I think what's gone wrong is that my manifest for my application is not good. Yeah, so let me add in my war. And let me try running it on the server again. Ta-da! Nope, I think this is just going to be one of those cases where it's not happy. So let me switch away and show you something that I think will work and will be cool, which is my carafe. So this is the same war running in carafe. I should also say, because of course when you work on a product, you hate to show two things, one of which is your product not working, and then the other thing is something else working. So I should make it very clear that the reason I'm having difficulties isn't because I was using WebSphere. The reason I was having difficulties is because my Eclipse has been used for that demo a couple of times, and every time I clean it up, the state gets a little bit weirder. So let me start up carafe. And so carafe is very small, it's very light. I've just got a command line here. And so if I do list, that shows me all my bundles. And carafe has decided that I really don't want to see the carafe internal bundles. So at the moment I have a completely empty carafe. But I want to install my war. So if I do install file, I can install my war. It's now installed, and this is one of the cool things about OSGi, is that bundles have a life cycle. So instead of being there or not there, at the moment it's installed, but it's not actually started. So if I try and start it, you can see I've got a problem again. But again, trust me, this problem is expected. So what it's saying is I had this Joda time dependency. I'd externalized it from my war, but I haven't actually added it to carafe. So it's definitely not going to start my war for me, because if I started my war, I'd just get an error at runtime. So what I can do now is I can install Joda time. I can install it using the Maven coordinates. So you can see now I have two bundles. If I start Joda time, I can now go back and I can start my application. And there we go. So now, if I go to the web, if I go to Firefox, and if I go to localhost 8181 block, I think, yes, is it Blockstacker Web? Let's try. Hooray! Got there in the end. Context paths are one of those things that combine so badly with demos because you always want to give yourself an interesting context path, and then at the time of the demo you cannot remember what your context path is. So then next time you learn from experience and you say, I'm just going to use /, I'm not going to put anything else in, which is fine until you go to do the demo and you go, I must have used the interesting context path, and you type it in. So far what we have is pretty much the same as I had when I had a war. But now I'm going to show one of the special tricks of OSGi, which is that I'm going to install something that provides an OSGi service. And my war in the source code, I did consume that service as well. So I was consuming it by JNDI. So I have this string displayer. It looks up an OSGi service using JNDI as a compatibility layer. So if it's not there, you can see nothing happens. But if it is there, something kind of magical happens. If I load my stringer, and then I start it up, if I go back to my web application on Firefox, I get different behavior. But now I can do even better than that, because now I think, oh, actually, I'm not so keen on that blue triangle. So I can stop it. And it's gone. So I've got this dynamism in my web application, and I can change the deployment of my system and have that reflected all the way through my application without having to restart anything. You'll notice that I didn't have to restart the web application. All I had to restart was that bundle that was providing a service. So that's quite cool, and I think quite a compelling use case for OSGi. So I'm going to step away from the computer while it's all still working. Are there any questions? There is, yeah. It's the question was about OSGi security and the support. So the enterprise specification hasn't added anything new for security, but all the OSGi security support that's there just carries forward, as you say. Are there any other questions? Okay, thank you very much. The slides will be published, and at the end there's a list of useful resources as well that you might find a good reference. And I think there's also a discount code for the book, which you might also find useful. So thank you very much.